Peter Hill Explains, where I invite you to join the science teaching conversation with me about energy. What is it? So this is going to be a little talk podcast while I'm driving. I've got to reach so many podcasts a day, so yeah, different varieties. But I'm going to talk about energy. What is energy? So it's a concept which really hasn't been around for a very long time. It's the word energy means the amount of work in something. So ergo means ergonomic for working. It's use energy as stuff which is used up in work, which is the original form of it, but it's actually one of these things which are hard to actually unravel. You have the very famous equation of energy. It's E equals mc squared, but we've got energy and we can say, well, the energy is in different forms. It can be in stored motion, heat, light, sound. We can say it's energy and we can add an adjective to it, and we mean at the end of the day it will result in something which can be measured in joules. So I just want to talk about a few things about this is off the top of my head, of course, but this is to do with the way relationship between temperature and heat of it. So the heat in an object is not necessarily the temperature of an object. So if I put a heat into an object, it doesn't necessarily increase in temperature. So the heat in an object is a measure of the kinetic and potential energy of the object, and or the vibrational energy and the kinetic energy. They're very subtly different things. So just hear me out. So I can put a lot of heat into some ice and it will change phase. It will change phase into water. So that's from a glass. So it's a glass transition. Yeah, because water is this, which is not. Well, ice is crystalline. Ice itself is not, even though it's see-through, it's not glassy, so it's a glass transition. So I can put heat energy into something without increasing the temperature of it. This is I can change it there. So let's go back and say that heat of an object is a measure, an arbitrary measure of the amount of work available in it, and it may to do with its temperature. It's the amount of stored kinetic and potential energy inside an object is the amount of heat internal to it. Now, one of the things I want to say is that one of the misconceptions is that something which is you hear it time and time again, and unfortunately as an examiner you have to mark it right, because that's what the teachers have told, and nothing of it ever moves forward, and that is that temperature is a measure of the kinetic energy, of internal kinetic energy of an object. Well, maybe it's a measure of, say, each particle is constrained to a location. It doesn't move, or effectively doesn't move within a boundary. So the particles are stationary. So even in a gas, they are stationary to within the meter size of the bottle that they're confined in. So there you go. But why would I object to saying, well, come on now, the kinetic energy, surely that is the measure? Well, a pendulum has a mix between, it's continually oscillating between maximum kinetic energy at the bottom swing and then potential energy as it goes. So the temperature represents, now this is critically the correct thing, is the vibrational energy of the particles. The vibrational energy, which is a combination of the kinetic energy in a restorative field, which, like the particle in a gas is restored by the wall of the bottle. In liquid, it's restored ultimately by the walls of the container for it. And in a solid, just making sure I don't get crashed as I do around this roundabout, the actual particles are in a restoring field, and so the particles do have kinetic energy at one point, but it's a store between kinetic and potential energy, and so you can see that where you're expecting, so you measure the heat transfers due to not the potential energy, but the kinetic energy of the particle goes over, hits, and how it does. So heat flows from a hot object to a cold object. So the cold object has a lot less oscillation, and so it's the kinetic energy component in heat which is associated with temperature, which transfers it across. So it's in temperature you are measuring the effective transferability of heat into your object. So there's a little bit of a subtlety there. And so you've got various things. So energy is the potential for work. So a hand grenade has the same amount of energy before you pull a pin and after you pull a pin. But in your energy accounting, so energy is an account sheet basically of the amount of work available. So you've got asset energy and actual liquid cash energy, and then you've got a loss of it outside. So the energy of your hand grenade has stored so many 1 megajoule, When it's pulled off within the box that you've got to look at, it's got kinetic energy. But as those particles move and energy goes outside this box that you're looking at, the energy dissipates from that area, and so energy, which is the work, can't be created nor destroyed. But in terms of the accounting of it, the energy goes somewhere. It's like money, forensic accounting going through it. So there's all these subtleties, and this is just the ideal podcast because it's just enough for me to get up home. I just drop my kid off at AFL, and our family will go and pick up our daughter. We're all on 10-minute counts. So this is trying to get across to you that energy is sort of one of these fundamental concepts like momentum that people have come at from different angles, and then people at the end want to teach you a simple definition. There is a simple definition, but you get very lost in doing it. So there's heat energy, which is the kinetic and potential vibrational energy of particles, say within an object, a liquid, and stuff like that. It's not purely the kinetic energy of your particle, because the particle comes to rest. The particle has got that kinetic energy stored because the particle isn't moving anywhere. Part of making the energy not flow is microscopically getting the kinetic energy to be converted into potential energy, and the particle to change direction. So really, it's the total energy of an object is half the kinetic energy and half potential energy, because they are the same. The potential energy and the kinetic energy depends on how you'd actually define it. But it is that kinetic energy that actually does the motion and the transfer of kinetic radiation. Now, that's sort of a naive, I suppose, view. There's that kinetic stuff definitely does transfer momentum into the momentum space of electrons. So there's a sort of electron and radiative heating. There is sort of convective. No, that's what you're doing, mate. You're gonna let me through? Thanks, mate. Okay, we're nearly home now. So this is just a podcast on this topic. I'll try and set it up more and more. You can see that these terms, people love teaching a term straight up and answering it and think, yes, got it through, and let's move on. But when they themselves don't understand the subtlety of the term, they can often lose it, and then when they're trying to teach the next level up, they haven't actually themselves understood the basis of it. So that's just a quick, off the top of my head, introduction into energy. Thanks for listening. podcast, another story comes to a close. It's been a pleasure sharing this moment in time with you. May you discover truly amazing things, understand them, and tell others. Thanks for listening.